Last class I've given you one numerical. Are you able to do that numerical? Anyone did? Anyone did that numerical or tried? I've given you a hint also. Let me share my screen. 33 came. Let me share my screen. My screen is visible. Please respond. My screen is visible.
No, ma'am.
No. Let's wait for some minutes.
Ma'am.
It is.
No.
No. Let's share once again. Now it is.
Ma'am.
Is my screen is visible? Hello?
Ma'am.
Yes. Okay. And let me know when
Yes.
my cursor didn't move. Okay? It doesn't move. Let me know. So I'll start the class.
Okay, ma'am.
How much participant? 36. Okay, fine. Okay, let's move to the class. So earlier we have discussed. Today we'll review the normal stress what we have studied. Then we'll define and discuss nominal stress, which is also called as engineering stress. Then we'll discuss what is true stress, and then we'll move to normal strain. So as we have discussed earlier that this is your existence, we have considered a structural member, we have applied a load. Let me note. Okay, we have considered a structural member and we have applied a tension, axial load on that and in tension direction. And earlier the length of the section was L. Suppose if you stretch a rubber band, suppose the shape of the rubber band is like this. This is your rubber band. Okay, when you stretch, it will regains its original shape. But when you stretch it again and again, then it will deform, right? It will deform like this. Its length become increase and cross sectional area used to decrease. So whatever I'm giving you an example of stretch member, you can take any structural member or any suppose
Ma'am.
yes.
Ma'am.
Yeah.
Not visible, ma'am.
It is not visible now.
Okay, let me try once again. Actually
We can.
here in my place rain will start. That's why I think network is giving issues and all. Let me share once again. How is the weather there? In your place weather is fine or it's raining? No. So now screen is visible? Yes? Type in the chat box. I'm not able to hear. The voices are not coming. Type in the chat box. Screen is visible or not? Okay. Perfect. So let's start. Let me know when the screen is not visible. Otherwise, I'll go on, and you won't understand anything. And just let me know when the words are not synchronizing with the screen also. So this is the structural member. I have stretched it. I have stretched it in this direction. Okay. After at some point, it will regain its shape. But when it fails, it gets elongated. Suppose I'm taking an example of rubber band. Suppose I have a rubber band of this size. Okay, this is my rubber band. I'm stretching it like I have stretched it for. I've given a load. Suppose below above its capacity area. Suppose I have stretched it for 2 weeks. So what will be the shape of this rubber band? It will becomes like this. Is it or not? Is it or not? Your rubber band will like this. But if you stretch a spring also, when you stretch a spring for some time, it will regain its shape. But after some time, your suppose this was your spring. I'm really bad at drawing. Suppose this was your original string. When you stretch it for regular days, after some time, it will hello. Your spring will becomes like this. It gets stretched out. So, in the same way, suppose if the original length of this bar is L, when you stretch, it will gives another length. Suppose earlier its length was 6 meter. After stretching or when it get fails, its length may become suppose 6.5 meter. So what is this delta? This delta is or nothing but this 5 meter, 0.5 meter. Got it? Your extra length, a member you have stretched it, you have applied an axial loading. When it gets original length was, ma'am, is the cursor supposed to? Yes, ma'am, the cursor supposed to be moving because in my screen it is. Just wait a second.
Hello, ma'am. Hello, you.
वॉइस नहीं आ रहा था।
Hello,
Hello. Now is it visible? Screen is
मैम
visible.
आवाज आवाज नहीं आ रहा है।
अभी
हेलो,
अभी आवाज आ रहा है
हाँ
कि
अभी
नहीं?
ठीक है मैम।
अभी ठीक है?
अभी आ रहा है।
हाँ हाँ ठीक है मैम।
हाँ ठीक है, चलो अभी बारिश आ रहा है. लेट मी शिफ्ट माय प्लेस. जस्ट गिव मी अ सेकेंड. ओके, आई केम टू माय टेरेस.
ओके मैम।
I came to my terrace to teach you all, but now it's raining, so I have to shift my place. Just wait a second. Go through the previous slides or previous notes you have made. Okay, just give me a minute to shift my place.
ओके मैम।
Ma'am, we can understand. We're facing the same problem, ma'am.
मैम केयरफुल।
Who is talking? Don't talk. Vika, mute yourself. Now my voice is audible to you. Are you listening? Hello? Now
Yes, ma'am.
screen is visible. Screen is visible?
Yes, ma'am.
Okay. Okay. So where we were, okay, this is our member. We have applied an axial load. We have L. So when I stretch this member to a certain extent, it gets filled and gets elongated. It gets elongated to a new dimension. It suppose earlier the length was 6 meter. Now the length becomes 6 plus 6.6 6.5 meter. So your delta part is what? The delta part is the extension, that is 0.5 meter. Okay, understood. So this is the L, this is the L plus delta, and this delta is your nothing but 0.5 meter. How much it gets elongated, that is your part. Okay, let's move to the next slide. So after when it gets stretched, if I cut a section, if I do a transverse cut on the section, so what we have studied, that when you do a transverse cut, there will be an two force, one in the perpendicular direction N and one will be in vertical direction V. Here P is nothing but equals to N if you equilibrium all the forces, and this shear force will become 0 because here there is no any other force. So V will become 0 simply. All of you do one thing, write your roll number in the chat box. At least I can give you attendance. Here it is raining. I may not take the class completely. Write your roll numbers. Students, write your roll numbers in your chat box. All of you wrote their roll numbers. My voice is visible to you all or not now?
Yes, ma'am.
Voice is visible now?
Yes, audio.
Let me take the attendance first. This is very important. Okay. Let me try to share my screen once again. Hope this time it will able to see? Is it visible?
Yes, ma'am.
Okay. Okay. So the member, if we cut the member, if we do a transverse cut on the member, we'll get two forces. One perpendicular to the axial and one vertical forces. So as there is no vertical forces in this direction, so if we equate these forces, we will become 0, and n is nothing but equals to p. So your axial forces will equal to normal forces, and shear forces is equal to 0. And we have also assumed that all the normal stresses in this direction will be uniformly distributed. Let's move to the next slide. Okay, so this is your structural member with normal stress and shear stress. So what is normal stress? We discussed normal stress is nothing but force per unit area perpendicular to the cut surface. So your normal force divided by area will give you normal stress. And we have considered the sign convention for the tension part. If the forces are in tension, we'll simply take positive signs. If the forces are in this direction or it compact the structure, so it will take the negative sign. In the same way, normal stresses, we have nominal stresses and true stresses. So what is nominal stress? It's the same normal stress, but here area will be your initial cross sectional area, and here actual area becomes smaller when the specimen fails. So suppose this is your specimen. I have stretched it out. When it stretch it out, it will become to a shape like this. Just understand, don't go with my diagram. It's scary. Okay, I think this is kind of okay. So earlier this cross section was this one. Your A naught will be this one, and this is the new area after fail. So this will be your A. This was your A naught, and this will be your A. So this A naught is your nothing but your initial cross sectional area, and this new A is your area which we get after this section has failed. When we call this section has failed, when it doesn't go back to its original shape, then this structure has failed. So your nominal stress will be normal force divided by initial cross sectional area, that is A naught, and your true stress will be N by A, the area which we got after the structure gets failed. So between these two, which one will be larger? Nominal stress will be larger or true stress will be larger? Which stress will be larger? Any idea?
True stress.
Hmm.
And true stress.
Why? Which true stress will be larger? Any idea? See, why this true stress will be larger? See, so this is your area. Area will become just wait a second. Okay. So this area is smaller and this area is larger. So when this quantity becomes larger, this quantity will automatically
আনচাৰ ল'ব গৈছে বুলি ভাবিছিলোঁ সেইটো আমি ফোন মাৰি আছিলোঁ
Hello? My voice is
দুইঘণ্টাৰ
clear?
মূৰত আলহী আহিছে নেকি?
Rupashri, please mute yourself. Hello. Okay, now my voice is not equal. Okay, so this area is nothing but this area becomes less. See, earlier the cross section was huge, so A naught will be more comparison to your small a. So when this area will less, so automatically this will become larger. When this value is more, this will become automatically larger, right? So your true stress is always be a larger value than your nominal stress. And in engineering purpose also we generally use nominal stress. We don't use true stress. But we should know what is the true stress also. Okay, for the engineering purpose we generally use nominal stress. Let's move to the next slide. So we come to the we ended the stress part. Now let's move to the strain. So what is strain? Strain is elongation per unit length. How much elongation have been done divided by L. See, don't confuse with the stress and strain. Stress comprises of area. In stress, we generally the stress calculates it needs your force per unit area. It needs force and area. But in strain, you need change in length by original length. You just need L value. Okay. Change in length means how much change has been done when the bar has been stretched out. How much deformation? Okay, your voice is not clear. Let's wait for 2-3 minutes. Due to rain, my network is pathetic now. Now it is okay. Hello. Please type in the chat box so that I can continue. And why
Yes, ma'am.
okay.
Not clear, ma'am.
Not clear.
Yeah, ma'am.
Now let me shift.
Yes, now it's clear, ma'am.
Okay. So just same with the stress, we have elongation also. So elongation is your change in length by original length. Suppose earlier I give an example that earlier suppose the length of this member was 6 meter and now it shifted to 6.5 meter. So what will be the delta value? Your delta value will be your 0.5. How? 6.5 minus 6 will give you 0.5. So your strain will be 0.5 divided by how much was the original length? 6. So you'll get the strain value. Okay. And one more thing, this value is dimensionless. See how it is dimensionless. Let me show you. Earlier, suppose your earlier length was your L is given you 6 meter. Then change in length is given you delta 0.5 meter. Or they can confuse you with the word that increase in length. Increase in length is your 6.5 meter. Sometimes they will give you directly delta value. Sometimes they will will confuse you and tell you that original length was 6 meter. Now the increase in length is 6.5 meter. So what is the delta? So delta is nothing but original. If original is 6, the new length is 6.5 meter. So your change in length will be 6.5 meter. So your strain is, as per this formula, change in length. So change in length is how much? 0.5 meter. And original length was 6 meter. Now this meter and meter will cancel out, right? So this will become dimensionless quantity. So your strain is dimensionless quantity. Again, for the sign convention, this tension causes elongation. When we stretch, this is in tension. When we stretch a member, we get elongated member. But when we compress a member, suppose this is our member, when we compress, it will be squeezed in, right? It will be somehow become like this, more cross-sectional area with small. It will be squeezed in. So compression causes shortening. It causes shortening of the member. Here, tension causes elongation of the member. Compression causes shortening of the member. So for the shortening, we have to take negative, and for the elongation, for elongation, we have to take positive sign. So with the strain, as we got for the stress, we got nominal stress and true stress. Same, we have normal strain, nominal strain, and true strain. So this nominal strain is used in engineering purpose. This delta by L naught, and for the true strain, we have delta by L. L was your initial length, and this was your length after fail. So based on this formula, simple formula, we have I have solved these two numericals right now. You have a flat steel alloy bar whose initial thickness is 10 mm and initial width of 60 mm. It is subject to a total axial load of 60 kN. Determine the nominal axial stress in the member. This nominal axial stress is nothing but here this nominal axial stress. Why they are saying axial stress? Because we have applied an axial force. So you have to find this value. Then in the second question, a flat steel alloy bar has an initial length of 900 mm. When subjected to an axial load of 60 kN, the bar elongates by 0.45 mm. Determine the nominal axial strain in the bar. So here you have to find the stress, here you have to find the strain. So this is the formula for strain, epsilon delta by L naught and stress N by A naught. Write in your copy and solve this to numerical. This is your question. First write this question, all of you. Write this question and then solve it. And
Ma'am, question is not visible.
question is not visible. Okay, okay, let me tell you the question. Let me dictate. I'll stop sharing, then my voice will be clear, I guess. Write the question. A flat steel alloy, bar has an has an initial thickness of 10 mm.
Ma'am, voice is not audible. Ma'am,
Voice
not clear. Hello?
voice is also not audible. Let me share my screen then.
Not clear, ma'am.
With Zoom, with WebEx, we have lot of issues. Now screen is visible. Screen is visible now.
No, ma'am.
No, ma'am.
My voice is clear. My voice is also not clear.
Oh my.
No, ma'am.
What will I do now?
मैम सुनाई नहीं दे रहा है.
सुनाई नहीं दे रहा है.
Ma'am, why don't you write the question in the box?
Let me do that. Good idea. Let me do that. Let me write the question itself. Okay, I'm writing the question in the chat box, okay? I wrote the first question. A flat steel alloy bar has an initial thickness of 10 mm and an initial width of 60 mm. It is subject to a total axial load in tension of 60 kN. Determine the nominal axial stress, or you can say engineering stress in the bar. And the second question is, a flat steel alloy frame bar which is having an initial dimension of 900 mm. When subjected to a total axial load in tension of 60 kilonewton, the bar elongates by 0.45 mm. Determine the nominal strain. Solve it and share the answer with me. Till then, I'll mark your attendance. Very easy. Just all the dimension has been given to you. All the dimensions given to you. You just have to know what value is given to you. What are the values given to you and what you have to find. I told you what you have to find. You just have to find the stress, find out the force and A value in the first part. If you have any confusion, you can ask me also. We'll discuss. But first, I want you to try this numerical. Very easy. It will hardly take 10 minutes. Anyone able to do? किसने किया? Answered? Be fast. Section A student gave me answer in 5 minutes. First question का answer 5 मिनट में दिया. Yes, what I want. And sound is totally not clear, can't hear you. I'm not saying anything. You just try the numerical. Try the numerical. Hello? Anyone able to do the numerical? Hello? 0.85 support. For which answer? Which one you are talking about? 1 or 2? Please write answers 1 or 2. Marker 1.1. Okay. So you are telling me the answer of question number 1 or 2? Answer of question number 1 or question 2? Two zero. Correct. Correct. So let me share the answer with you all. Am I audible? Hello? Screen is visible? Screen is visible? See the screen? I've shared the answer. Hello? Am I audible? Hello? Hello?
Hello?
Am I audible? Am I audible?
Hello? Hello?
Hanya tunggu sini ada.
Ma'am, tapa mak.